Hello everyone and Ramadan Kareem. We are Muhammad Makti, or as we call it here, Muhammad Akasha, and my colleague Fadi and Zaki. And today we will explore how Tesla uses deep learning to revolutionize autonomous driving. So let's see. Autonomous driving is one of the most exciting technological advancements of our time, and Tesla is leading the charge. Their goals to achieve full service driving, or as they call it FSD capability, making transportation safer, more efficient, and convenient for everyone. But this journey is not without its challenges. Tesla must navigate complex ethical dilemmas, regulatory hurdles, and technical limitations while ensuring their systems are robust and reliable. In this presentation, and with my colleague, we will break down Tesla's technology, discuss the challenges they face, and answer three critical thinking questions. The first one: how can Tesla ensure the ethical use of its autonomous driving technology? And the second question: what strategies should Tesla adopt to improve the diversity and the quality of its training data sets? Three, question three: how can Tesla balance innovation with regulatory compliance? Let's drive with Freddy to show our case overview.
Hello everyone, I'm Fadil Bakri and now I'm going to take you through Tesla case overview and technologies used in Tesla vehicles. With Tesla's autonomous driving, which is a system relies heavily on deep learning. It is a subset of machine learning that use neural networks to identify patterns and make predictions for complex data. Here is how it works. Tesla vehicles are equipped with an array of sensors, cameras, radar, and ultrasonic sensors that continuously collect data on driving conditions, road signs, traffic patterns, and pedestrian behavior. Then this data transmitted to Tesla centralized servers where it undergoes processing to train the company's neural network. Second, HydroNet. HydroNet, one of the unique innovation keys which developed by Tesla. Let me explain how it works. HydroNet is a multitask learning approach where a single neural network performs multiple tasks simultaneously, such as object detection, lane detection, and depth estimation. This improves efficiency and accuracy. Additionally, Tesla used transformer networks which excel at processing sequential data, a crucial feature for understanding temporal relationships in video feeds. Once the models are trained and validated, Tesla deploys them to customer vehicles through over-the-air updates, which is the OTA. This means customer can receive improvements and new features without needing to visit a service center, and guarantee of the continuous enhancement to be sent to customer vehicles anytime. And at last, I'm going to speak about the real-time decision making, like emergency brakes or avoiding sudden obstacles. Tesla uses edge computing, where data is processed locally into the vehicle to minimize latency. While this system has incredible potential, it's not without challenges, as Zaki will explain next.
Hello everyone, I'm Ahmed Zaki. I will discuss challenges in Tesla autonomous driving. Tesla path to full autonomy and fruits with challenges. Let's break them down. As shown in this presentation, the key challenges in deep learning for autonomy as technical challenges, ethical challenges, regulatory challenges, and adaptation hurdles. The First challenge is data quality and diversity. Autonomous systems require diverse data sets to perform reliably in various conditions. For example, Tesla needs data from rural roads, snow-covered highways, and chaotic urban intersections. Rare scenarios like a child running into the street during a thunderstorm are particularly hard to capture. Without these edge cases, the system might struggle in real-world situations. The next challenge is regulatory hurdles. Regulations vary widely across regions. In the US, Tesla must comply with NHTSA standards, while in Europe they face stricter EU rules. This legal framework often lags behind technological advancement, creating a delay in deployment. When we go to the ethical concerns, imagine this scenario. A Tesla car encounters an unavoidable accident. Should it prioritize the safety of its passenger or pedestrians? This is known as the trolley problem, and its major ethical dilemma. Addressing these concerns requires a public discourse and collaboration with ethicists. As shown here, the last challenge is system reliability. Tesla AI must work flawlessly in all conditions: rain, snow, and darkness. Any inconsistency could lead to accidents, undermining trust in technology. These challenges highlight the need for Tesla to balance innovation with responsibility. Now, Alkasha will tackle the first critical question: how can Tesla ensure the ethical use of its autonomous driving technology?
Welcome back again. Most important question about ethical dilemma, as you see on this picture on the left. How can Tesla ensure ethical use in unavoidable accidents? First, transparency is the key. Tesla must make its decision-making process more transparent, while deep learning models and inherently complex efforts to explain their reasoning can build trust. For instance, Tesla could develop a dashboard that shows user why the car made a specific decision. Second, Tesla should create a scenario-based ethics framework. For example, in an unavoidable collision, the system might be programmed to minimize overall harm. However, defining this guideline requires public input and collaboration with ethics. Third, data bias mitigation is crucial. If Tesla's training data is biased, for example, if it underrepresented certain demographic, the system might make unfair decisions. Tesla must actively identify and address bias in its data. Finally, regulatory oversight is essential. Independent bodies should audit Tesla's system to ensure they meet ethical standards. Public dialogue is also important. Tesla should engage with stakeholders to address concerns and build consensus. Next, Fadi will discuss how Tesla can improve the diversity and the quality of its training datasets. Let's go, Fadi.
To improve the diversity of its training datasets, Tesla must first focus on expanding data collection. Autonomous systems need to work reliably in all conditions, whether it's navigating chaotic urban streets in India, icy highways in Norway, or rural roads in Australia. Tesla's current approach relies heavily on its fleet of vehicles, but there is room to grow. They should prioritize collecting data from underrepresented regions, such as rural areas, mountainous terrains, and countries with unique driving cultures. For example, capturing data in regions like Sub Saharan Africa or Southeast Asia could help Tesla understand how drivers behave in less regulated traffic environments. Additionally, Tesla must focus on edge cases, rare scenarios like sudden weather changes or unexpected obstacles. By systematically gathering data in these situations, Tesla can ensure its models are prepared for real world unpredictably. Let's move on to the next step, enhancing data quality. Once Tesla has expanded its data collection, the next step is to enhance data quality. High quality training data is critical for building reliable deep learning models. First, Tesla should invest in improved data annotation. This means using advanced tools and rigorous quality control to ensure every object, whether it's a stop sign, pedestrian, or a cyclist, is labeled accurately. Human in the loop techniques, where human validate machine generated labels, can help catch errors and improve precision. Second, Tesla must ensure its sensors are always calibrated correctly. Misaligned cameras or faulty radar reading can lead to incorrect data, which compromises the model's performance. Development system to detect and correct sensors error will go a long way in maintaining data reliability. Finally, Tesla should implement data validation pipelines to identify biases and anomalies in its datasets. For instance, if the system is trained mostly on daytime, it might struggle in low light conditions. By addressing these gaps, Tesla can create a more balanced and representative dataset. Now, let's talk about leveraging data augmentation. Finally, Tesla can leverage data augmentation to fill gaps in its datasets, while real-world data is invaluable. It's not always feasible to capture rare or dangerous scenarios. That's where synthetic data comes in. Tools like Carla and NVIDIA Drive Sim allow Tesla to generate realistic simulations of edge cases, such as sudden weather events or emergency braking situations. These simulations complement real-world data and help train the system for unpredictable scenarios. Tesla can also apply data transformation techniques to exit data like rotating images, flipping them horizontally, or adjust brightness and contrast. This creates variation that makes the model more robust to different conditions. And last, Tesla should explore generative AI models to create synthetic data for extremely rare but critical scenarios, like a child darting into the road during heavy rain. But combining real-world data with synthetic augmentation, Tesla can build a truly comprehensive dataset. With these strategies, Tesla can significantly improve the diversity and quality of training datasets, leading to safer and more reliable autonomous systems.
So, let's address how Tesla can balance innovation with regulatory compliance. As we know, balancing innovation and compliance is tricky, but Tesla can succeed by the following. Tesla can succeed in balancing by engaging regulator early, establishing open communication channel with agencies like NHTSA and the EU regulators, share detailed information about Tesla's technology, testing procedures, and safety measures. Tesla can use phased rollouts as well. Start with limited deployment in controlled environment, like highways or designated zones, gradually expanded as technology matured and regulations evolved. Let's go to the published safety data. Demonstrate reliability through rigorous testing and validation. For example, Tesla could publish reports showing billions of simulated miles driven without accidents. This step will help Tesla accelerate deployment while maintaining public trust. And finally, Alkasha will wrap up with our conclusion.
Before we conclude, let's take a moment to watch this short clip of Tesla's latest innovation, the Cybercab robotaxi prototype. This is futuristic vehicle represent Tesla's vision for the future of autonomous transportation. Unlike traditional approaches that rely on LiDAR and high-definition maps, Tesla's Cybercab uses advanced computer vision and deep learning to navigate routes safely and efficiently. Notice how sleek and minimalistic the design is. This is Tesla's commitment to pushing the boundaries of what's possible in autonomous driving. So let's see this video. As we have seen, the Cybercab highlights Tesla's dedication to innovation. Their journey reminds us that achieving full autonomy requires not just cutting-edge technology, but also ethical consideration and regulatory compliance. Enjoy watching. In conclusion, Tesla's integration of deep learning into autonomous driving showcases the transformative potential of artificial intelligence in the automotive sector. By leveraging vast amounts of data, cutting-edge algorithms, and innovation like the Dojo supercomputer, Tesla continues to lead the industry toward a future of safer, more efficient transportation. However, challenges remain ensuring ethical use, improving data diversity, and balancing innovation with regulatory compliance are critical for Tesla's continued success. Addressing these issues will not only enhance Tesla's system but also set a blueprint for the broader adoption of autonomous driving technology. As we have seen with the Cybercab prototype, Tesla is poised to revolutionize mobility once again. Their journey reminds us that innovation requires not just technical excellence but also collaboration, transparency, and responsibility. At the end, thank you for watching. We are excited to read your all comments and answer any question. See you next video inshallah. Thank you.